Hello and welcome to all of you for attending such an important session on NEC NFPA 70 2026 edition. In this session, we will discuss about Chapter 2, that is Article 242, our voltage protections and our voltage protection devices. When it comes to the scope of this article basically consists of three parts. Number one, part one, that is all about general requirements, connection requirements of our voltage protection and our voltage protection devices. Part two is all about such protection devices that is installed in premises wiring less than 1000 volt AC or 1500 volt DC. Part three is all about the such protection devices that is greater than 1000 volt AC or 1500 volt DC, that is used in a higher electrical power system or electrical system. So there are four types of overvoltages in the electrical power system. Number one is zone one, that is lightning surges, which is comes to massive jug external spike. Number two is switching surges, that is short or rapid interval spikes from equipment, switching of substations or toggling of the switches. The third one is our transient overvoltages, that is our voltage sags, and there are certain fluctuations in electrical power system. Number four is utility disturbance, that is external grid and anomalies and disturbances occur in the power system. So when it comes to part one, that is general our voltage protection requirements, the clause 242.2 is all about mandatory listing. All SPDs less than 1000 volt or 1500 volt shall be explicitly listed. 242.3 tells us that SPDs and such arrestors shall never be installed in a refurbished or we can say reconditioned state. It should always be installed with new or factory new or we can say listed equipment for that specific application. 242.9 is all about active indication that all SPDs must provide clear visual indication that it is working or functioning properly or might be some issue. So indication must be very clear. Now we will discuss part 2, that is our voltage protection requirement, SPD less than 1000 volt AC or 1500 volt DC. So for part 2, use is not permitted, that is close to 42.2 tells us about three conditions where SPD must not be used. Number one, voltage bridge, that is SPD should not be installed for voltage greater than 1000 volt AC or 1500 volt DC. For second condition, that is incompatible system. We can say that SPD should not be installed on an ungrounded system, impedance grounded system, or corner grounded delta system. Unless these devices are specified or can be used by a specific application or for a specific application as per OEM instructions. The third one is the underrating and the fault current. SPD should not be installed where the rating of the SPD is less than the maximum continuous phase to ground voltage rating of the system, or we can say for that is used for a certain application of a power frequency. Furthermore, 242.8 tells us that the short circuit current rating of the SPD must always be greater than the short circuit current rating of the systems or conductor where it should be installed. So accordingly, for 242.8 further clarifies in this slide. You see there is a variable system fault current that is 35 kiloampere. So we cannot use SPD of rating 22 kiloamperes on this application. So we can always use higher ratings short circuit current matching SPDs. That is, for our application, we require 35 kiloampere and greater. So 50 kiloampere SPD rating is feasible and appropriate for our application. So for bottom side picture shows that SPD must be connected to all ungrounded conductors. Each phase requires a dedicated path to the ground. As shown in the picture, one part or one conductor is connected to each phase, that is L1, L2, and L3, specifically for all ungrounded conductors, and the other is connected to the grounded conductor and have same potential or equipotential surface, and there is no shift of any grounding, or we can say floated potential. This slide shows the core mechanism of the diverter, or we can say surge protection device. Surge protection device is connected to the power system, electrical system, and its one end is connected to the phase, and the other end is connected to the ground. So it is clear from the picture that any surge strikes or any transient voltage strikes on the system, the SPD safely diverted the surge into the ground and protects the equipment. This slide shows the type of the surge protection devices as per Article 242. There are 4 types of SPDs that are or can be used in our system. That is type 1, type 2, type 3, and type 4. When it comes to type 1, that is 242.13, the SPD should be or must be installed in the utility service entrance, that is on the main breakers, and connects to the ground conductor or services ground terminals. So for type 2, that is 242.14, the SPD must be installed on the load side, or we can say on the distribution level, or the feeder, or we can say MCC, VFDs, UPS, and other distribution main feeders. For type 3, SPD should be used on the point of the use, that is for sensitive electronic devices, PLCs, computers, relays. So it should have a minimum 10 meter to 30 feet from the service entrance. So this distance should be maintained. For type 4 SPDs, that is 242.18, it can be installed as per OEM instructions and for particular application as is specified and strictly advised by the original equipment manufacturer. Accordingly, this table shows the types of the SPD devices and their summary. For type 1 SPD device that is used for voltage less than 1000 volt, it is used for service locations, main LV panels or main panels or the main panels of the electrical system. Type 2 SPD device is used for less than 1000 volt, and it is used for distribution level feeder or distribution level system, that is MCCs, VFDs, and other feeders. For type 3 SPDs, it should be used for voltage less than 1000 volt and is used for point of application or branch circuit, that is sensitive electronic devices, PLCs, relays, computer outlets. And for surge arrestor that is greater than 1000 volt, it should always be used for high voltage electrical equipments, conductors, or power system. That is, for, let's suppose 11 kV transformer or any substation that is greater than or higher voltage system. So SPD installation and grounding rules. So 242.13, 242.20, and 242.50 tells us about how we connect the SPD and how we connect it to the grounding system. So this clause tells us that whenever SPD is installed at the service end or the service point of the electrical system, it follows 4 points or the 4 key ingredients. That is, it should be a grounded service conductor. Number 2, grounded electrical conductor. Number 3, grounded electrode for the services. Number 4, equipment grounding terminal in the service equipment. So it is all clear in the picture that SPD, one end of SPD is connected to the phase and the other is connected to the point where it is defined by four important and critical level or the grounding levels. So for 242.20, where used at a point on a circuit, the SPD shall be connected to each ungrounded conductor. So it is always be connected for all ungrounded conductor, and its other end is connected in either four ways that is described in this slide. So it should be properly grounded. So when it comes to part 3, our voltage protection requirements, SPD when connected to the system that is greater than 1000 volt AC, 1500 volt DC. So 242.2, that is stepping up to surge arresters. The rating or the duty cycle rating of the surge arrestor shall not be less than 125% of the maximum continuous operating voltage that is available at the point where the SPD is installed. So when it comes to system calculation, if there is a system is a solidly grounded system, then the maximum continuous operating voltage is always equal to phase to the ground voltage of the system or the conductor. And for impedance or ungrounded system, the maximum continuous operating voltage shall always be equal to phase voltage of that system or electrical conductor or equipment. So accordingly, part 3 describes how we can select the surge protection device or the surge arrestor for voltage greater than 1000 volt. As per 242.2, surge arrestor shall always be greater than or equal to 125% of the continuous operating voltage. So for system that is 11 kV, and we can, if multiply it 1.25, that is 125%, then the value comes out is 13.75 kilovolt. So you have to select the surge arrestor that is equal to or greater than 13.75. So if surge arrestor available in the market is in 15 kilowatt, then it should be or must be selected for this application. So what are the benefit of selecting it? We can protect transformer insulation, motor windings, and switch gear from lightning and heavy surges. So when it comes to SPD installation and grounding, 242.24 is all about low voltage and less than 1000 volt AC or 1500 volt DC. And for 242.42, that is belong to high voltage greater than 1000 volt AC or greater than 1500 volt DC. So this code tells us about how we can install the surge arrestor appropriately as per OEM instruction. That is, one part is connected to the bus line or ungrounded conductor, and the other is connected to the ground, and shall strictly avoid bands or unnecessary cabling or unnecessary distance. So it is clear from the picture that on the left side, it is a good practice how to install the SPD with the ground, and the other point or the other right hand side tells us that the SPD is installed inappropriately and not following the OEM standards. So it can create hazards that the surge impedance increases. If any surge strikes, then this impedance cause the system not to safely divert surge to the ground and may cause our or we can say our voltage or instability in the system, and then there might be some damage to the system. So it is clear that how we can safely or we can say install SPDs in our system. So when it comes to cables or the cabling from the low voltage or high voltage, SPD is connected to the ground. So for left hand side, it tells us about 242.28, that is low voltage system and belongs to part 2. So maximum size is 14 American wire gauge copper or 12 American wire gauge aluminum. And when it comes to right hand side, it belongs to 242.52. That is for part 3, and it's all about high voltage surge arrest. So cable used from SPD to the ground shall always be 6 American wire gauge copper or aluminum. So this slide belongs to the cable selection from the point where SPD connected to the ground. When it comes to 242.54, it tells us about how we can connect surge arrestor, or we can interconnect it with the electrical power system, conductor, transmission line, or ground. So the physics of an electrical surge. This picture clearly shows that if we cannot use or install surge arrestor, and we cannot connect it appropriately with the ground, then there might be a shift of neutral, or there might be a floating potential, or there might be a rise of the ground potential. So it can harm the transformer and the system. So right hand side shows us that how we can install as per standard or as per safe practices, so that all secondary and arrestors and the secondary of the transformer are in the same and equipotential, and there will be no rise of the potential or our voltage or any unseen or unforeseen situation. So right hand side is the best example how we can connect it surge arrestor with the ground, and bonding with the secondary of the transformer and at the same potential. So this slide is the carrying slide, or the ongoing slide of the NEC 2.54. So this shows how we can connect surge arrestor and create a safe surge arrestor ground path. So it is very clear from the picture that all surge arrestor primary and secondary are in the equipotential surface, and the surge or the lightning side can safely be diverted to the ground without rise of any unwanted potential to the system or electrical conductor. So as per NEC 242.54 compliance matrix, it is divided into three sections, and the three methods how we can connect surge arrestor and interconnect with the electrical system. Number one is direct metal bonding, that is part A. So it is also belongs to solid metallic link between surge protection device and the ground. So this is ideally for highly grounded networks, water pipes, or utility grids. The second part is all about spark gate devices, where direct metal bonding system is not appropriate. So we use surge protection, or we can say spark gate devices, so that there will not be any rise of the voltage, or we can say such device or we can say lightning strike can easily divert it to the ground with the use of we can say metal oxide surge protection or surge diverters. So ideally, it is used in system where direct bonding is unsuitable, and there is we can say metal oxide, we can say surge protection devices are used. In part C is special permission when both direct metal bonding and spark gap devices, such protection device and its applications are failed or cannot be used. Then there is a special permission is required from a custom authorized, or we can say authority having jurisdiction, so that it can approve the design that is specifically for any special application. We can say offshore system or any special oil and gas substation. So it is always before special application and required AIG approval. So accordingly, when it comes to direct metal connection, so you can say direct metal bonding is permitted when existing ground conditions are robust. So the picture clearly shows how surge diverters and the secondary of the neutral is connected to the ground, and both are at the equipotential surface. So there is no any rise of unwanted voltage, and surge or the lightning side can safely divert it to the ground, and the ground distance shall always be lower and drastically improve, we can say, lightning current dissipation. So 242.5A1, that is leveraging water pipe grounding. So it is also one type of application that is used for we can say grounding and bonding, and we can use underwater metallic water pipes network. So one point of the surge diverters is grounded with one point of the buried metal water pipe, and the other point of the secondary of the neutral is connected on the same pipe, so that both can be used and at the same equipotential surface while using this metallic water pipe. So when it comes to multi-ground neutral system, direct bonding is authorized for utility distribution networks. As seen in the picture, that each poles or each utility system is separately grounded, and we can say separately drive system. So what happened for 1 mile multi-grounded neutral system, we can use 4 ground connections. So what are the benefits of it? We can reduce lightning energy, stabilize neutral voltage, improve fault current path. So this multi-ground system is very beneficial for direct bonding. So when direct bonding is inappropriate, it cannot be used, then we can use the spark gap alternative, or surge, we can say surge protection device or surge arrestor that have metal oxide, we can say semiconductor, that is voltage dependent. When surge strikes the system, it increases its resistance and safely diverted the voltage, and the safely diverted the lightning strikes to the ground by changing its variable resistance. So in the picture, in normal operation, there is no current flow, but when any lightning strikes and we use spark gap application, then extreme voltage is generated in the system, then it changes its resistance and safely grounded the lightning strikes. So for 242.54B1, for ungrounded primary system, the voltage shall always be greater than 2 times the primary voltage, but strictly kept at maximum 10 kilowatt. 10 kilowatt. So in picture there is a calculation: 11 kilowatt multiplied by 222 kilowatt. That is breakdown voltage, and that is as per NEC. But the NEC limited maximum to the 10 kilowatt. So accordingly, if we have a 2 ground connection, so two ground point, then the minimum distance to the both conductors or grounding paths is always 6 meter or 20 feet. So it always prevent ground loop effects and dangerous touch voltage when it used as per standards. So accordingly, for 2.52B2, multi-grounded primary adjustments. So accordingly, for heavily multi-grounded system, the NEC tells us that the spark gap breakdown voltage should always be less than or equal to 3 kilowatt. As shown in the picture, it always be 3 kilowatt and less than 3 kilowatts. Why? Because the system is already stable, and a low threshold and the low resistance of the surge arrestor fastly discharges the lightning strikes or the switching strikes and protect the equipment at the earliest and on the priority. So for 242.54C, we have to give required special permission if both bonding system and the spark, or we can say spark arrestor or spark gaps method is not used, then we can use a special application and required approval from the authority having jurisdiction. So this is reserved for complex custom grounding systems and environments such as offshore platforms and custom industrial substations. So accordingly, when the neutral wire is connected or is encapsulated in the metal conduits, then it should always be follow the standard of Article 250, and the conductor must be properly sized and mechanically protected. So as per 250.64, bonding prevents extreme heat and induced voltage from the magnetic effect and protects grounding conductor and the system. So there is a real case study of the 13.8 kV transformer as per NEC Article 242 for voltage greater than 1000 volt AC or 1500 volt DC. So a picture clearly shows how the system is installed. As the left side, there is a wrong installation. You can see there are certain loops and the secondary side, and there are certain anomalies. So it is not appropriate and can create nuisance relay tripping and increases the grounding resistance. So for the right side, there is appropriate installation as per NEC standard. So you can say there is a stable neutral reference, stable grounding reference, and there is a reduced impedance, and we can say that the system can easily handle the surges and divert it safely. So for low voltage less than or equal to 1000 volt, what are the problems? There are frequent PLC failures inside the oil and gas plant. Why? Due to the internal switching surges. So how the intervention of the SPD comes out? Install a type 2 SPD that is directly connected to the MCC, we can say VFDs and the UPS and the other distribution feeders. So what is its function? It ensures ultra short SPD leads and upgraded to the proper grounding. So it will work appropriately and faster to divert the surges. So what are the results? Nuisance tripping drastically reduced, reliability of the highly sensitive PLCs, DCS, electronic relays, VFD systems restored. So when it comes to voltage greater than 1000 volt for 11 kV transformer, suffering can be suffered from physical damage due to the lightning strike and heavy switching surges. So when metal oxide, we can say surge arrestors near terminals are installed, and that installation should be always be greater than or equal to 25% rating of the system voltage. So when it is installed as per standard, and establish a short straight grounding electrode pod, it can now we can say the result will be complete protection of the transformer insulation and winding from subsequent lightning surges and lightning strikes or heavy switching surges at the substation or utility site. So when it comes to conclusion, we can learn from this article the 5 golden rules of the mitigation. Number 1, prioritizing ground. So we learned that bed grounding equals non-existing surge protection. Surge energy must have a safe exit with low impedance to the ground and with appropriate installation of the SPD device. Number 2, keep cable short. So we have learned that always use a standard cable, and cable should not be wrap up, or we can say always use the minimum cable to the ground, so that its resistance should never be increased and can easily divert the surge energies to the ground. The part 3 is verifying voltage rating. So always ensure that the SPD's rating is always greater than the available fault current or short circuit rating of the system. Otherwise, it can create a catastrophic failure or explosion in the plant or the system electrical equipment. Number 4 is shield sensitive equipment. So we have learned that sensitive electronic devices like PLCs, DCS, and VFD systems are highly susceptible and require dedicated protection. And we can learn that we can use type 3 SPD to protect it. So point number 5 is never recondition. So always use a new device that is a listed device, and shall never be used retrofit, or we can say reconditioned or refurbished SPDs. It shall always be used as per standard and new equipment. So when it comes to conclusion, NEC Article 242 ensures resilience through proper selection, routing, and coordination. That's it from today's session. I hope you enjoy the session. We will meet in the next session. Up till that, thank you. Bye-bye.